Williams, a trained mathematics teacher. Welcome back to my channel, Bloom Your Math, and A is your grade. In my previous videos, you learned how to add, subtract, and multiply matrices. If you missed those videos, I will link them in the description box below. It's now time for our Take 5 series. And today we're going to work 5 questions on matrices. So let's get started. Question 1 says, if P equals 2310 and Q equals -2121, evaluate 2P plus Q. Now, evaluate means to find the value of the expression when the variable is replaced by a given matrix. In this case, the variable is replaced by a given matrix. So let's see what that really means. Now first, I'm going to write 2P plus Q, which of course is an expression, doesn't have any equal sign. And now we're going to write back our 2, and we're going to replace P with the matrix 2, 3, 1, 0. Now recall that 2P means 2 multiplied by P. That's what 2P means. So we are multiplying 2 by the matrix P. Then we're going to add the matrix Q to the result. Okay? Now, in our previous video, I said that 2 is called a scalar. And what the scalar does is to multiply every element in the matrix by 2. So let's go. 2 times 2, 4. 2 times 3, 6. 2 times 1, 2. And remember, 2 times 0 is 0. 0 times any number is 0. Awesome. And we're adding that to -2, 1, 2, 1. Alright, now it's reduced now to adding 2 matrices. And the principle or the concept is that when you're adding 2 matrices, you must add the elements that are in the same position. So just recall that 4 is in the same position as 2, and this 2 is in the same position as that 2. This 6 is in the same position as that 6. Okay? So let's go. I set up my brackets, and I'm adding 4 to -2. Then I'm adding 2 to this 2 in this first matrix. Is in the same position with this 2. This 6 in the first matrix is in the same position with this 1. So I add them together. And then the 0 is added to 1. Okay? So all we need to do now is to tidy it up. And again, directed numbers are a part of this question. So let's see how much you remember. You have 4 and you owe 2. So you still have 2. 2 plus 2, 4. 6 plus 1, 7. And 0 plus 1 is 1. And that's the final answer. And that is question 1. The solution for question 1. It's pretty easy. Okay? Okay, it's time for question 2. It says if P equals 2, 3, 1, 0, the matrix, and Q equals the matrix negative 2, 1, 2, 1, evaluate PQ. Now remember that PQ means P multiplied by Q. So we're going to go straight to the problem. So P is the matrix 2, 3, 1, 0, and we're multiplying it by the matrix Q, which is negative 2, 1, 2, 1. Okay? Now remember that the form of our answer is row 1, column 1, row 1, column 2. Row 1, column 2. And then row 2, column 1, row 2, column 2. That's a pattern for our answer. That's a pattern that you need to get. Alright, good. So we're multiplying the first row, row 1, by column 1 to give me this answer. First element in the row times the first element in the column. 2 times negative 2. So you know your answer size is a 2 by 2 matrix. Okay? They're compatible. So 2 times negative 2 plus 1 times 1. Now we're moving on to row 1, column 2. Column 2. First with first, second with second. First with first, second with second. 2 times 2 plus 1 times 1. Okay? Then we're finished with row 1. Moving on, row 2. And row 2 with column 1. Again, first with first, second with second. 3 times negative 2 plus 0 times 1. Row 2, column 2. First with first, second with second. 3 times 2 plus 0 times 1. And let's close the bracket. And we're going to tidy this up now. Let's put in our brackets and find the values of each of these. 2 times negative 2 is negative 4 plus 1. 2 2s 4 plus 1 times 1 is 1. So remember the answer size is 2 by 2. 3 times negative 2 is negative 6 plus 0 times any number is 0. 3 2s, 6, and 0 times 1 is 0. So our final answer is you have 1 and you owe 4. So you still owe 3. Give up the 1 and you still owe $3. 4 plus 1, 5. Negative 6, you don't have any money and you owe 6, so you still owe 6. You have some money, $6, and you don't owe anybody any, so you still have that in your pocket. And that's the answer for question 2. Okay, we are back now at question 3, which says that we are going to be multiplying two matrices of different sizes. So if T is equal to 3, 0, 0, 1, and G is equal to the matrix negative 2, 3, you're asked to evaluate TG. Alright, so T is being replaced with the matrix and G is replaced with this matrix. And TG simply means that we are multiplying T by G. So here is T, 3, 0, 0, 1. And here is G, 2, 3. Now remember we said in our videos, previous videos, that not all matrices can be multiplied. So we have to first check their compatibility. So this is a 2 by 2 matrix. And this is a 2 by 1 matrix. 2 rows and 1 column. They can be multiplied. And the answer size has to be a 2 by 1. And remember, I like to use asterisk to indicate what a 2 by 1 matrix really looks like, okay? Now, let's go. Same principle. We're multiplying the rows in the first matrix by the column in the second matrix. So the rows, this is row 1, and we're multiplying it by the column in the second matrix. There's only one column to contend with. So let's go. 3 times 2. And let us see if we missed off anything. Here G is negative 2, so we have to be careful that we don't miss off the signs. Alright? Just double checking to see if we wrote the question correctly. 3 times negative 2, that's first with first, plus 0 times 3. Then we're going to multiply row 2 by column 1. So this is row 1, column 1, and we're now trying to find row 2, column 1. Again, first with first, second with second. 0 times negative 2 plus 1 times 3. Let's go. 3 times negative 2, negative times a positive gives me a negative. 0 times any number gives me 0. 0 again times any number, whether it's negative or positive, is 0. 1 times 3 gives me 3. Again, you don't have any money and you owe somebody $6. Do you have any money, Lee? Not at all. So you still owe that $6. And now you don't have any money. 0 plus 3 is 3. Alright, so we're adding 0 plus 3. Everybody knows that that is 3. And that's the final answer. Is this a 2 by 1 matrix? Check. Yes, 2 rows and 1 column. Now, if you had written your answer like this, it would be wrong. So it is important to know the answer size, what it looks like, the pattern of your answer, and how you're going to write it before you start all your calculations. Draw up your lines and start working. So that's a 2 by 1. So that's the end of question 3. Okay, so let's now start again. We are at number 4. Given that A equals 1, negative 1, 4, 2, and B equals negative 1, 2, 3, 5, evaluate A squared plus B. Alright, so we have to first tackle what A squared means. So let me write the solution. Now, from your algebraic skill, you should know that A squared means A times A. Just like 5 squared means 5 times 5. And t squared means t times t. Alright? So we're going to move on now to this question. A squared means we have 1, negative 1, 4, 2. Now, please do not do this. Did you hear what I said? Do not do this. Don't do that. Do not say 1 squared is 1, 4 squared is 16, negative 1 times negative 1 is positive 1, and 2 squared is 4. Don't do that. That is wrong. Because we just said a while ago that a squared means a times a, which means that we are going to be writing the matrix A twice. And remember, we don't need to write the multiplication sign. It's understood. So we're writing this same matrix, A. We're writing it twice. Okay? And once we work that, and get that result, we're going to be adding our answer to the matrix B. So let's take it one step at a time. Alright. So I'm going to try to create more space by writing it a little bit smaller over here. A squared is equal to 1, negative 1, 4, 2. Only reason I'm doing this is because I don't want you to forget the R1, C1. Row 2, row 1, column 2. Row 2, column 1. Row 2, column 2. Just like what we did a while ago. This is just a reinforcement. But the trick with this question is that A squared means that you must write the matrix twice. You don't square each element in the bracket. Okay. So now that you get that concept clearly, let's move on. And I'm going to move a little faster here. This is row 1 and column 1. Okay? So work with me quickly. Row 1, column 1. 1 times 1 plus 4 times negative 1. Row 1, and I'm not circling column 2, but you can see column 2 has two numbers, 4 and 2. Row 1, 1 times 4, first with first, second with second. Get that so far? Now negative 1 times 1, that's row 2. Negative 1 times 1, and 2 times negative 1. Row 2, column 2. First with first, second with second. Okay? Now we're going to write our answers. Tidying it up again, A squared. So 1 times 1 is 1, plus 4 times negative 1 is negative 4. 1 time, and you don't need to draw the line, you know, it's just for teaching purposes why I draw this line. Because I don't want you to miss the fact that your answer has to be a 2 by 2, 2 rows and 2 columns. Okay? 1 times 4 is 4, and 4 times 2 is 8. Negative 1 times 1 is negative 1, and 2 times negative 1 is negative 2. Get that so far? Negative 1 times 4 is negative 4, plus 2 times 2 is 4. So what's our final answer? A squared is equal to 1 plus negative 4 gives me what? Yes, negative 3. Negative 1, you owe 1, and you owe 2. In all, you owe 3. 8 and 4, 12. And negative 4 plus 4 is 0. Now that's just the answer for a squared. So what I'm going to do now is finish it up. A squared plus b. Our answer for a squared is negative 3, negative 3, 12, and 0. Okay? And I'm going to just use a red marker just to highlight that a squared answer is negative 3, negative 3, 12, 0. And b is this matrix. Negative 1, 2, and 3, 5. How do we add two matrices? We add elements that are in the same position. So negative 3 is in the same position as negative 1. 12 is in the same position as 3. This negative 3 here below in the second row is in the same position with the 2. And 0 is in the same position with the 5. So our final answer is negative 4, negative 1, 15, and 5. Don't forget to write the word answer. Okay. So that's it for number 4. We're now on to our last question in our Take 5 series. Number 5 says A equals 1, negative 3, 2, 5 for A. And remember, we use a capital letter to name a matrix. B equals B, P 4, negative 5, negative 4. And you're in part I, it says write A plus B as a singular matrix. Okay? As a singular matrix, which means that we're going to combine A and B. That's the gist. Let's go. So our solution is A plus B. The variable A has matrix 1, negative 3, 2, 5. And B, the matrix B has elements P, 4, negative 5, negative 4. And this is pretty easy, isn't it? Again, it's the same principle. You know, you don't have to work 20 questions, you know. The principle remains the same for all of them. So let's go. We're going to be adding elements in the same position. So 1 is in the same position as P. So that's 1 plus P. 2 is in the same position as negative 5. So that's 2 plus negative 5. Negative 3 is in the same position as 4. And 5 is in the same position as negative 4. Now, again, we're simplifying. Now, 1 plus P. What's 1 plus P? 1 plus P remains 1 plus P, because 1 is a number and P is a letter. And we cannot add unlike terms. Get that? So 1 plus P cannot be simplified any further. Let me just get that bracket looking a little bit more decent. 2 plus negative 5, you have $2 and you owe 5. So you still owe 3. You have $4 and you owe 3. You still have 1. You have $5 and you owe 4, you still have 1. Give up the 4, you still have 1 left in your pocket. Okay? So let's go to the second part now, part 2. It says, given that A plus B equals 3, 1, negative 3, 1, calculate the value of P. Now we already know in part I that the value of A plus B as a singular matrix is this answer. Okay, so that answer there is A plus B. So we say since A plus B, or I like to say from above, A plus B, that sounds neater, from part I, A plus B is equal to 1 plus P, 1, negative 3, 1. Also, we know that A plus B is also equal to 3, 1, negative 3, 1. Because that was given. You agree? So, if A plus B is this matrix and A plus B is also this matrix, what can you conclude? Yes, they are equal. They are the same. They mean the same thing. Alright? So, this matrix is the same as this matrix. Kind of like a scale. And for part I, this matrix is A plus B. And for part 2, yes, this matrix is also A plus B, meaning that the equal sign tells us that they mean the same thing. So we can, if they mean the same thing, we can put them together with an equal sign between them. So now we have 1 plus P, negative 3, 1, 1, with an equal sign because they both mean the same thing. For the scale to be balanced, 3, 1, negative 3, 1. And which concept of matrices are we heading here? There's an equal sign between two matrices. There's one on the left and one on the right. Left hand side is this matrix, right hand side is this matrix. All that we're saying is that, remember this? When we had A, B, C, D, something like this, not necessarily the same thing. B, Y, X, Z, and let's put another letter, M. Then A is equal to Y and C is equal to X because they're in the same position. It's the same principle here. So clearly, this one and this one are in the same position. They're equal. You couldn't have 1 here and negative 1 here. That would make sense. 1 is not equal to negative 1. And this one is in the same position as this one. Right? They're equal. There's nothing that we can do. And focusing on what they ask you for, you're required to find they're in the same position. They're equal. You couldn't have 1 here and negative 1 here. That would make sense. 1 is not equal to negative 1. And this one is in the same position as this one. Right? They're equal. There's nothing that we can do. And focusing on what they ask you for, you're required to find the value of P. This 3, negative 3, is in the same position as at negative 3. Nothing can be worked out. Those two values are the same. Same thing with the others, 2. So now we are left with this one. 1 plus P is in the same position as 3. So 1 plus P and 3 mean the same thing. Guess what the answer is? You can't guess, you know. For remember that it must make sense. Your answer must make sense. The value of P has to be 2 because 1 plus 2 equals 3. And again, all you're doing is subtracting 1 from both sides. So P is equal to 3 minus 1. P is equal to 2. And that's the answer for the value of B. So take a moment, take a shot at it. You can pause the video and you can write off the notes. Okay? That concludes today's class, guys. I post videos weekly. If you like this video, then definitely like, share and subscribe. You may ring the notification bell to alert you when I upload new videos. So, I'll see you next time. Bye.